Hey, this is Unit 6, Statistics, Lesson 6, Green Skittles. Where did all the green Skittles go? All right, this is our fourth day of learning about binomial random variables, and today we're actually going to convert the binomial random variable to the normal model when we are able to. We're going to learn about those conditions. Okay, so first of all, excuse me. The first thing what we did is I had a pack of Skittles and a party-sized bag that had 1,200, and 20% of them are green. And I took 100 Skittles and I gave 100 Skittles to each group. So the first of all thing I'm asking, is it a binomial setting? So we have to use spit. And we say success, failure, green or not. Yes, they're either green or not. Probably the same, each is 20% are green. Independent. Okay, this one is interesting. Independent means one doesn't affect the next, but if I take one out, then I've taken one out of the mix. Now I'm going to have a greater, and if it's not green, I'm going to have a greater chance that I'm going to have the next one be green. So, but because I'm sampling without putting it back, that's without replacement, without putting it back, I have to be careful. Only if my sample is less than 10% of my population am I okay with calling it independent. So 100 is less than 10% of 1,200 because 10% of 1,200 is 120. So we're saying it's okay, it can be independent. Trials is a set number, we're doing 100, and so we're set and we're okay. All right, the binomial distribution applet that I showed you on the previous one's the same thing. You go to StatsMedic and go to applets, binomial distribution, and this is what it draws for you. And then if I say what's the probability of most getting 11, it will tell you, it'll solve it for you, or you can go ahead and put in your calculator. And let me remind you how to do it on your calculator. So for calculator, you're going to go to, from your calculator page, you're going to go to Menu, Stat, Distribution, and letter B, which is binomial PDF, or CDF, excuse me. And your lower bound, because this asks at most 11, 0. Upper bound is going to be 11. Your mean is going to be, or excuse me, your probability is going to be 0.2. And you are looking for your N, which is 100. And that will give you the same thing as you get with going to the app. Your approximate shape, you can see that this is about normal. It looks fairly symmetric. And that's because of this large counts condition. If you use your mean, NP, and you have 10 or more, and you use your ones that was my failures, which is also 10 or more, then you're going to be an approximately normal model. So what that means is I have two things. Back to success, failure, right? Success, how many successes do I plan to have? Well, I plan on having 0.2 times 100. I plan on having 20 successes because 20% of my 100 are planning on being green. So that means if I have 20 successes, I'm going to have 80 failures because 20 plus 80 is 100. If 20 and 80 are both bigger than 10, then that meets my large count condition and the shape will be approximately normal. Let me go over that again. Basically, I have two things. I have successes and failures. If both of those are both bigger than 10, the shape of my distribution is going to be approximately normal. Okay, the formula, which we went over last time, is NP, and the standard deviation is square root of NP1 minus P. If we did this with a normal approximation, we would go to normal CDF. My lower bound is going to be negative infinity. My upper bound is going to be at 11. My mean is going to be at 20, and my standard deviation is going to be at 4. And you're going to get 0.0122. As you can see, it is really close to 0.0126. Not exactly the same, but that's why it's called a normal approximation. So it's going to be very, very similar. You only can do that if I have 10 successes and 10 failures. So the large count condition says you can use a normal distribution to model a binomial distribution only if my successes and my failures are greater than 10. And then, of course, you're going to do that is your mean is going to be the center, your standard deviation is going to be square root of NP1 minus P, and then you can either use a z-score or you can use the normal CDF, the lower bound, upper bound, mean, and standard deviation to be able to get the values. And and then, of course, this is menu, stat, distribution, normal CDF. Okay, On the check for understanding here, the application, showing that it's approximate normal. Again, you're going to be just doing NP. So I have 1,500 as my N and 18.2% is my P. And so I get 273, and that's bigger than 10. And then N1 minus P, and that's 1227, and that's bigger than 10. So clearly we're okay. If I ask you to calculate the mean and the standard deviation, you would just do NP to get 273. That's what we got up here. And the standard deviation is NP1 minus P to get almost 15 adults. To use the normal approximation, it's asking to get a sample of that can between 243 and 303, which this would be my lower bound, and this would be my upper bound. And this here, of course, my mean, which we already found, was 273, and my standard deviation is here. So I would do normal CDF. Remember, menu, stat, distribution, normal CDF, lower bound, upper bound, mean, and standard deviation. And that's going to get you the same value as this one here, which is about 95.53%. Or you could have done it with the z-score table as it's shown here. This could be under coverage. And so because if we had a sample of less than 243 American adults that identify themselves as Hispanic or Latino, we would expect that Hispanics and Latinos being underrepresented in the sample. So likewise, if we had more than 303 adults in the sample that identify them as Hispanic and Latino, they would be potentially overrepresented in the sample. It's really, really important to make sure that your representation of your population is the same as in your sample. If, for instance, if I want to know how many people like horror films as their favorite film, and I happen to ask, and I'm asking 100 people, and I happen to ask 80 of them as men and 20 of them as women, then I might get a different answer than if I have about half and half men and women, or if I had 80 women and 20 men. Because gender sometimes can affect the type of movie that people prefer to watch. And so therefore you have to be very careful and make sure that your sample is well represented of your population. I hope that helped, and I want to see you on the next one, and I hope you have a wonderful day. Bye-bye.